Alright, and welcome to the very last video for part one of the summer assignment. So we're going to do just one more example of basic trigonometry. Again, in this question, I'm going to look for a missing side. And as you can notice, hopefully you know by now, this is the hypotenuse that's missing. Now, we had another problem in the very first example where I was looking for a missing side, and I used Pythagorean theorem. However, that's because I had two of the three sides. In this one, as you notice, I have a missing side, the hypotenuse. I have this side, and I have this angle. I don't have this side, so I can't use Pythagorean theorem, as I don't have two of the sides. I have a side, I have an angle, and I'm looking for the hypotenuse. So the question is, okay, what do I have to use? Well, ask yourself this very important question. What does this side and this angle have a relationship with? What I mean by that is, what's a relationship? As in, are they adjacent to each other? Are they opposite of one another? Well, this side is opposite of this angle. Again, to be adjacent, you need to be basically right here. You need to be adjacent. You need to be touching the angle. You need to be touching this corner. This side is opposite of this corner. So, let me erase this real quick. Boom, boom, boom. There we go. Since these are opposite, and this is a hypotenuse, ask yourself, which one, sine, cosine, or tangent, deals with opposites and hypotenuse? Well, if we go back to that little expression I showed you earlier, so this thing's not writing too well. Toa. Okay. The one that has opposite and hypotenuse is sine. Okay, so I want to use the sine. I think the batteries are running low on my little mouse pad thing here. Okay, so what's the equation? Well, it'd be sine theta equals opposite over hypotenuse. Now, the goal is I want to get hypotenuse by itself because that's what I'm looking for. Well, we have a problem. It's on the denominator right now. So I need to bring it out of the denominator. How do I do that? I multiply both sides by by hypotenuse. I'm going to multiply both sides by the hypotenuse in order to get it out of the denominator. So that cancels there, and I'm left with hypotenuse times sine theta equals opposite. Now, again, I don't want hypotenuse, I don't want this sine theta here, I want hypotenuse by itself. So to bring the sine theta over to here, all you have to do is divide both sides by sine theta. Boom. Now the sine thetas cancel. And here's my final equation. Hypotenuse equals opposite over sine theta. Now, a lot of people ask, well, when do I know when to use inverse sine or inverse cosine or inverse tangent? And when do I just divide both sides by like tangent theta, sine theta, cosine theta like I just did here? Easy. When you're looking for an angle, that's when you use inverse, sine, cosine, or tangent. When you're trying to find a side and you want to bring the angle to the other side, then you just divide both sides by a sine theta, a cosine theta, or a tangent theta. So again, when you are looking for the angle, that's when you use the inverse sine, cosine, or tangent. When you're trying to find one of the missing sides and you have to get rid of a sine, cosine, tangent and bring it to the other side, then you just divide the whole thing. Sine, like I just did here. So just FYI. So let's plug all this in now. So this is going to be, opposite is 12. So do 12 divided by sine 36. Just type in a calculator. And since I'm dividing, I'm going to use the rule fewest sig figs. Both of these have 2 sig figs. So it is 12 divided by sine 36. And I get 20.415 blah, 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 blah. Well, again, I only want 2 sig figs. So, to do that, oops, I'm gonna write out part of it. I'm gonna write out the first couple numbers. 20.4. Okay, again, look at the number next to it. It says, oh, keep that as 0. So the answer is 20. But we have a problem. I did this one as a little tricky one. This is only 1 sig fig. Remember, how can I make this into 2 sig figs? Very good. Put a bar over it. Exactly. To make this 2 sig figs, just put a bar over that 0. And then, there you go. That's it. Box in my answer, and I'm done. So that's basic trigonometry. We are going to be doing trigonometry all year. I mean, it is so vital. You get this down probably more than anything next to equation manipulation. I would put this almost on par with manipulating equations as to importance for the entire school year. It is so important. So important. Okay. Thanks for watching, and you are officially done with the videos for summer assignment part 1. Good job, or good luck on that upcoming test you have to do online. Don't forget, print off the trigonometry questions. Unfortunately, they don't show up on the test. I don't know why. So you have to print off those trigonometry questions. A little advice, I would do those before taking the test. That way you have the answers right away, and it will help you save up time on a little bit harder questions. So that's just a little cheat you might want to try. But otherwise, good luck with that, and don't forget to do the second part of the summer assignment, which actually will take a very lengthy amount of time, and use all your resources. Use Moodle. I'm trying to update those videos as I go along for the Unit 1. Look online, look anywhere. Okay, I know it might seem tough, but you can do it. In fact, this past school year, the kid who took AP Physics got a 4. A 4. If you don't know, that's extremely high. That is a rare grade. It takes a 3 to pass. The highest you can get is a 5. So a 4 is extremely good. So kudos to that person for scoring that high. And I know all of you can do it too, but it takes a lot of hard work. And I know you can do it. Bye-bye.